Hello and welcome to our YouTube channel. In the previous video, we talked about getting familiar with Tinkercad. In this video, we'll be talking about getting familiar with your Arduino Uno board. So, let's start. What is Arduino? Arduino is a microcontroller-based open-source electronic prototyping board which can be programmed using an Arduino IDE, which means Integrated Development Environment. So it is basically a compiler. It is open source because its design and original source code is made available for free. So experienced circuit designers can make their own version of the module, extending and improving on it as they see fit. Arduino Uno is not the only Arduino-based microcontroller board. They have others like the Arduino Nano, Arduino Mega, Arduino Mini. Let's take a look at how the Arduino Uno looks like, since that's what we'll be dealing with. This is how it looks like. And let me start by introducing some of the major components of the Arduino Uno board. We have the reset switch, we have the digital pins, we have the USB connector, we have the TX and RX LED, which is located here, which stands for transmitting and receiving, USB interface chip for the USB connector, the crystal oscillator, the microcontroller unit MCU, the voltage regulator, the power port, and the analog input pins. Okay, we'll be explaining each of the components step by step so you can understand how they work and how it functions. Okay, the USB connector. USB connector. This is a printer USB port used to load program from the Arduino IDE on the Arduino onto the Arduino board. The board can also be powered through this port. So it is basically used to transfer the program from the IDE to the board, and it can also be used to power the board. This is our USB connector. This is the USB cable. Next, we have the power port. The Arduino can be powered through an AC or DC adapter or a battery. The power source can be connected by plugging in a 2.1mm center positive plug into the power jack of the board. The Arduino board operates at a voltage of 5 volts, but it can withstand a voltage of 20 volts. If the board is supplied with a higher voltage, there is a voltage regulator. It sits between the power port and the USB connector that protects the board from burning out. So this is our power port. This is the voltage regulator. So like I said earlier, the Arduino board can withstand a voltage of about minimum of 5 voltage to 20 volts, and it can do that with the help of a voltage regulator. Which can help step down the voltage, but it is recommended that you use the specified voltage, which is 5 volts. It's safer that way. Microcontroller. This is one of the major components in the board. It is the prominent black regulator chips with 28 pins, which is used to interface with its environment. Think of it as the brains of your Arduino. The microcontroller used on the Uno board is the Atmega 328 by Atmel. Okay, let me show you what it is. This is the microcontroller unit. So as I said, it has 28 pins, so it uses it to interface with its environment. This is also the version of this is called the Atmega 328P, created by Atmel. So this is like the brains of the Arduino Uno. all your programming comes into this chip. Everything is designed, everything that is on this board is designed to work with the Arduino to a chip. Let's go on to the next slide. The microcontroller. Analog input pins. Okay, these are our analog input pins. Over here, we have just 6 of them. So let's just go into it. The Arduino Uno has 6 analog input pins labeled A0 to A5. As you can see, A0 to A5. This pin can be used to connect and read analog input signals and convert it to a digital signal which the system can understand. This pin just measures voltage and not current because of the high internal resistance. Hence, only a small amount of current flows through the pins. Although these pins are labeled analog inputs by default, this pin can also be used for digital input and output. So this is the analog input pins. This analog input pins is connected to something we call an ADC, analog to digital converter. So it takes analog signals from devices that use analog input signals, DC motor, cell, and the rest of them. Those analog inputs and convert it to a digital signal that your microcontroller can understand. Next up, we have the digital pins. You can find this labeled digital 0 to 13. These pins can be used as either an input or output pins. It can be used to read on, off type input. E.g., if a button is pressed on by setting high or off setting low. When used as input, they read signals connected to them. When used as output, the pins act as power supply for the components connected to them. Pins labeled with this symbol, this wave sign, 3, 5, 6, 9, 10, and 11. This pin acts as normal digital pins, but are also capable of pulse rate modulation, which turns voltage high and low at different frequencies. It is used for driving inertial loads like fading LEDs, motors, and servo motors. These are your digital pins, 0 to 13. So there are 14 of them. Can be used to read inputs and output signals, just like your ones and zero, which your computer understands digital code. So what happens is that, for example, you press a push button by setting it high, it sends 1 to it. Let's first note that your push button is an input device, so it sends signal. So it sends signal to the Arduino Uno. So when you press it by setting it high, it sends 1 to the digital pin. And when you leave it that is off, it sends 0. So your digital signal helps collect those signals and transfer it to the microcontroller for better interface. That is what the digital pins are there for. Okay, let's continue. We have the reset switch. This is the reset switch. What does it do? When the switch is clicked, it sends a logical pulse to reset pin of the microcontroller and runs the program again from the start. This can be useful if your code doesn't repeat, but you want to test it multiple times. Maybe you're having a little issue with your microcontroller. Maybe the program is not reading well. You can use the reset switch for that. The next one is a crystal oscillator. This is it. And Arduino uses 16 megahertz crystal oscillator. So let's check out what it does. This is a quartz crystal oscillator which takes about 60 million times a second. On each tick, the microcontroller performs one operation. For example, addition, subtraction. In the Arduino IDE, we have what we call like a loop. So this loop repeats program. It helps repeat the program for a certain number of times. And this, what makes it possible, is the crystal oscillator. So what happens is that when your program is running, it runs about 16 million times in a second. See, that's very fast. Very, very fast. Amazing, right? We have the USB interface chip. Okay, this is the USB interface chip here, close to our TX and RX LEDs. This is it over here. So, what does it do? Think of it as a signal translator. It converts the signal in the USB level to a level that the Arduino board can understand. So, this is like the communicator between the USB and the microcontroller. So, it helps converts the signal that is coming in from the USB, which is the code, to what the Arduino can understand. Next up, we have the TX and RX LED. This is it over here. So it's located close to the USB interface chip. So what does it do? So TX stands for transmit, RX stands for receive, as I said earlier. These are indicator LEDs which blinks whenever Arduino board is transmitting and receiving data. So let's say you upload the code. Anytime you upload the code or data is being communicated to the Arduino microcontroller board, what happens is that your TX and RX blink. It states or indicates that there is a transmission and receiving of what data. So what's happening is that your compiler is talking to your Arduino Uno, and your Arduino Uno is also sending back the same thing, also sending back its own signal. Just like that, the communication is going on. And what helps us know that it is actually working is the TX and RS LED. So thank you. We're going to be stopping here for now. Please look forward to our next video, and I would like you to subscribe to our channel to support us.